All right, I'm going to get into chapter 9, where we talk about real numbers, and we'll eventually get into right triangles. Hopefully, you watched the quick videos yesterday from Khan Academy talking about squares and square roots, so you have a basic understanding of them, right? We talked about exponents before and powers, right? Meaning 3 to the second power is really 3 times 3, which equals 9. All right. And just like with addition and subtraction, how they're inverses of one another, meaning they cancel each other out. That's what a square root does, right? For example, if I take the square root of 9, I'm really finding what times itself, right? And that's going to be equal 3, right? So what times itself? What's that number that's multiplied by itself to give me the number underneath the root? Now, in the video, you saw that this notation, this radical notation or root, okay, it's also called a root. Um, there's an understood 2 to be right here because you can have higher roots, and we're not going to talk about those right now. But that right there could be a 3, it could be a 4. It's simply the same thing as this could be 3 to the third power, right? Which would be 3 times 3 times 3, and that would be 27. So just like we can have higher powers, we can have higher roots as well. But we're only going to be looking at square roots today, and so there's not going to be a number that's written there, right? 3 squared, right, was 9. This is understood to be a 2, right? A square root. When you see just this radical symbol, it's understood to be a 2. So what we're going to look at today is how to find squares and square roots, and we're also going to learn how to estimate them. Okay, now um, when you hear the term perfect squares, it's the squares of whole numbers, right? For example, 1 squared is 1. That should be a 4. 2 squared is 4. 3 squared is 9. 4 squared is 16, right? 5 times 5 is 25. 6 times 6 is 36. Um, and so you should know these perfect squares. All the way up to 15 would be a good place to stop, at least up to 100. All right, but start getting used to knowing that 11 times 11 is 121, 144 is 12 times 12, and so on. Right? If you want to pause and write these down, that might be a good idea just to have them until you get used to seeing them. And the reason is that allows us to estimate square roots. Okay, now um, the term square root, it's one of two equal factors of the number, right? Meaning what times itself gives me that number. So the square root of 9 is 3 because 3 times 3 is 9, right? The square root of 16 is equal to 4, and that's because 4 times 4 is 16. Now, we look at the perfect roots to help us understand, but I can find what the square root of 15 is, right? What times itself is 15, and I can use my calculator to do that. I know it's going to be a little bit less than 4 because the square root of 16 is 4, and the square root of 15 is smaller than that. So it's probably going to be 3.9 something. Um, these right here are important notes. Every positive number has a positive and negative square root. Okay, this symbol right here refers to the positive value, right? But I could say, what is the negative root of 16? And it would want negative 4. And here's why it has both a positive and negative. Because we're trying to find what times itself gives me 16. And 4 times 4 equals 16, but so does negative 4 times negative 4, right? Because negative times negative is positive. So we have two different values that we can have, both a positive and a negative. The root symbol is called the principal root, right? And that's implying the positive. If it wants you to find the negative, it puts it out in front. It says, what is the negative root of 9? Now, not to be confused with the square root of negative 9. Okay, that's impossible. Okay, negative numbers do not have real square roots. And if you type it into your calculator, it'll tell you an error, right? Because you can't take an F, because if you think about it, it's something times itself. Well, if I times a positive times a positive, I get a positive value. And if I times a negative, I get a positive value. So there's no number multiplied by itself that can equal -9. All right. So this is not possible to get a real solution to that. All right. So let's look at some examples. Okay. First off, getting used to the terminology. The radical sign is just this symbol right here. And it's also referred to as root. Okay. So radical and root, same concept there. So we're going to look at just finding square roots of perfect squares. And it says if possible, right? We'll look at what is not possible to find a root of. So here, this is implying the positive root of 25. So what times itself is 25? The answer is 5. Here, it wants the negative root of 49, right? And that would be 7, right? Because -7 times -7 gives me positive 49, right? Similar here, 5 times 5 is 25. Now this one right here is asking for both roots, right? So I should have two answers for this. The positive root of 144 is 12, and the negative root of 144 is -12. Okay, so I can have positive and negative, right? Each root comes as 2, right? A positive and negative. So if it's just the root symbol, it wants the positive. If it gives you a negative out in front, it wants the negative root. Here, this is saying it wants both possible roots, the positive and the negative. Here, this one is not possible. And notice the difference, right? The negative on the outside saying the negative root. This is saying the square root of -100, and that's not possible. So when the negative is on the inside of the root, it is not possible to get a real solution. And then here, what times what is 36, right? Or what times itself, I should be more specific, right? Because there's a couple combinations to get 36. But 6 times 6 is 36. So my root here would be 6. All right, those are fairly straightforward with the perfect squares. Now let's look at a few examples that are not perfect squares. We want to do two things. We want to be able to approximate. Okay? And like I said, we use perfect roots to approximate. And then we're going to use a calculator. So it's important to be able to find that button on your calculator. But you should know approximately what it is. For example, if I had a number line here, all right, and this is 0, right? Well, we can have square root of 1, right? Because 1 times 1. Then 2 would be the square root of 4, right? So I'm going to write the numbers on here. 1, 2, 3, 4, 5, right? And I'm going to write their perfect roots up top. So this would be the square root of 9. This would be the square root of 16. This would be the square root of 25, and so on. So for example, if I wanted to approximate the square root of 14, okay, well, I look here. This is square root of 9. This is square root of 16. So square root of 14 comes somewhere in between those two, right? Between square root of 9 and square root of 16. Well, I know the square root of 9 is 3, and the square root of 16 is 4. So I know it's going to be 3 point something, okay? And if I were to guess, right, look how far away. It's only 2 away from this root, and it's 5 away from this one. So if I were to guess, I would say somewhere along the lines of 3.8. All right. So essentially, when you're approximating, you're trying to find, right, and so that'd be closer to 4, right, approximately 4. When you're trying to find the approximate, you're looking between what two perfect roots does it fall, and which one is it closer to. And this is just a guess right here. So I'm going to show you on Desmos how to find the square root. So if I look at this, here's my square root symbol. So I'm going to do the square root of 14. And so I was a little high, right? I was a little high there. It was 3.7 instead of 3.8, right? 3.75. 4, but we'll just go to the nearest tenth. That's 3.7 when I use my calculator. But you can get an approximate answer by using the perfect roots. So let's look at this. I know that the square root of 81 is equal to 9, right? And that's a little bit bigger than this. And I know that the square root of 8 is 64, right? Sorry, square root of 64 is 8, excuse me there. And it falls in between. It's closer to 9. This is probably going to be, and it wants the negative root, approximately negative 8.9 is what I'll guess. So it's close to negative 9. So if it wants you to approximate, you say which one it's closer to. So it'd be negative 9. And then I can go to my calculator and say, what is the negative root of 80? Oop, I said 89. 80. So it's negative 8.9, right? And that's about what we guessed there. All right. So if you would, pause the video here, and I want you to see if you can approximate these next three, and also use whatever calculator you have to find the actual value for the square root. Okay. And if you're using the TI-30, which a lot of you are, it's a great calculator. If you find the squared button right above it, you can see the root symbol. And I'll pull up a picture of it in the next video here when we on pause so I can show you. But you hit the second function to be able to get to that. All right, so pause here and see if you can figure out those three. All right, so let's see how you did here. So first off, square root of 39, right? I know the perfect squares, 36 and 49, it falls in between those, right? And that's 6. Square root of 49 is 7. So I know it's going to be 6 point something. It's only 3 away from here, and it's 10 away from here. So it's going to be closer to 6 than it is to 7. All right. And we'll find out the exact answer using Desmos. But if you have one of these, TI-30s, great calculator. You see on Amazon, it's only about $13. But if you look right above the x squared, you can see the square root symbol. All right, and I'm pointing to it on my, I guess I can probably write with this. So if you look at this symbol right here, okay, so to get that, you would hit second and then the x squared button, and that would give you your root symbol right there. So if we go on Desmos, I think I can do this now. Okay, so if we go on Desmos and we wanted to type in the square root, so I'm going to go square root of 39, right? And we get 6.2. So the square root of 39 was 6.2. That's my exact, right? It was closer to 6. That was my approximate. If I look at 113, it's between the square root of 100 and 121, right? So this is 10. This is 11. So it's going to be 10 point something. And it's 13 away from 100. It is 8 away from here. So it's going to be closer to 11, right? So 10.6, 7, 8, something in those lines. So if we check, let's go 113, 10.6, right? So the exact using calculator, 10.6. I shouldn't say exact. We're still approximating because we're rounding that off at 10.6. Square root of 13, right? Square root of 9, square root of 16 are my perfect square references. That's 3. This is 4, so it's going to be 3 point something. Square root of 13 is 4 away from 9 and 3 away from, so it's going to be a little bit closer to 4, 3.5 something, 3.6 something. And if we figure that out, square root of 13, 3.6. 3.6. All right, so that's how you approximate, right? Which one is it closer to? And then using your calculator, right? And that's very important to be able to find that function, because I don't know exactly what the square root of 39 is unless I use my calculator. All right, I can approximate it, but I don't know exactly unless I use my calculator. All right, so try the following problems starting on page 439. If you have any questions, please let me know. Have a great day, and we'll talk to you soon.